I've read and seen on certain websites concerning the Philco Safari that many enthusiasts who own a Safari say that in general it's reasonably safe to start the Philco up or the Safari up with the existing capacitors inside. Now, honestly, I bought this Safari and it was pretty beaten up. I mean, the case was broken down, the picture tube was dislocated, there were a few parts missing, like the battery holder, which is completely missing, and the antenna is missing. Also, the accumulator connector, as you can see, is pretty corroded, and one of the wires has detached itself. So, to say that I trust this chassis to work properly would be a little bit of an overstatement. So I've been observing the insides of the chassis, and well, obviously it's transistor driven, although according to the schematic there are also two miniature rectifier tubes somewhere inside the guts of the machine. But I don't want to hurry it up too much. So what I intend to do, actually, and as a first step you might say, is to unmount the left PCB of the TV, which is this one. Yeah, and by left I mean if you look at the front of the TV, well, this is the left side PCB. It contains the IF and high frequency part of the TV mainly, perhaps the amplification stage too, whereas the top board, which you see there with a special kind of early type transistor here, would probably be the board used for deflection of the deflection coil. As you can see here, this wire here goes to this board. So in my opinion, this PCB and this transistor are high voltage deflection coil driving or drivers. I don't have the schematic handy for the moment, but I think that's what it is. Interpreting the wiring and all that, I feel pretty confident this is indeed the picture deflection PCB. So, and that's actually reasonably high voltage. Okay, so then you see there, you see the tuner part up there where I'm pointing at, and the whole high voltage part of the TV is behind this plate, so on the inside up here. But I'll leave the high voltage part for what it is right now, and what I intend to do now is to unmount this board. Now, for those of you who are familiarized with the Philco TVs, and certainly those of you who are a little bit familiar with the Philco Predicta series, will certainly recognize these connections, which are wire wrapped, which seems to be, at least to me, a typical Philco produced product. Philco was apparently quite happy to wire wrap wires to make connections instead of soldering them. So that will make it a little bit harder for me to unmount the PCB. Also, the PCB is not only screwed on to the chassis frame, which you see here, but it is also soldered on by points like these. It's my guess that you could say the grounding of this PCB is also grounded to the chassis. So that will pose a little bit of a problem to unmount it. Anyway, what I intend to achieve by unmounting it is that there are a few capacitors you see here. This one and that one over there, and then that one. Also, there is one very big electrolytic down there. You see it by the power transformer, which is used to charge up the Safari battery. So my intention is to try to unmount the paper caps and the electrolytic and any other electrolytic I find inside this radio, and well, change them for fresh new capacitors. So I'm really trying to resist the urge to connect it up and fire it up, because confidence I have in this machine is low. I really have no clue as to the state of it, and if I watch the wires down there which go to or which are attached to a soldering lug which is right next to the electrolytic. Hang on. Let me see. So right next to the electrolytic, you see those wires there. Those two wires. Let me zoom in. So those two wires there look charred. So whether that's a result of soldering, poor soldering, or the fact that they overheated somehow, well, I don't want to take the risk. So I definitely want to change that capacitor at least. But to get to it, as you can see, it's quite cramped inside the chassis of the Safari. I really need to unmount at least one of the two boards. And I think if I can unmount this board, that will give me quite a bit of access space. I managed to unmount the left PCB from the chassis of the Philco, as you can see. Now, to undo the chassis, you need to do you need to do the following thing. As you can see here, there is this part, which is a connector to the tuner box, which is up there inside the chassis. So I will point at it. So this box, and to the box there is connected this high frequency wire with, I would say, kind of a kinch type connector. So you need to undo this connector first before you pull it out, or before you pull the PCB out of the chassis. And while you disconnect this from the tuner up there, you have to be careful not to damage any other part. Now, it turned out this connector was connected up to the tuner rather stiffly. So what I did was actually use a pair of pincers, these, yeah, with a curved beak, and I gripped inside this connector by the neck, and then I used the sides of the tuner box as a fulcrum point to lever the pliers down, as it were, and push the point of the pliers up, which effectively levered the kinch connector out of the tuner. But while you're doing that, you have to pay extreme attention not to damage any wires or parts inside the chassis. So the longer curved pliers you have, the better it is. If you have, I could say, curved needle nose pliers, but with very long nose pins, let's say, then that would be a lot better than this one. I mean, this is just a small needle nose plier, and it just did the trick, but had it been a lot smaller or shorter, it wouldn't have worked. So, once you've got this disconnected, this plug, you need to undo 6 screws of this type. Yeah, it has a hexagon head and a washer, and it's a, I would say it's type of quick lock bolt or nut screw. I don't know how you what the exact name of this type of screw is, but it has a bolt head and a quick lock thread. So anyway, there are 6 of these, and you need to undo each of them. You've got no choice. So there's one up here, then there's one down there, then there are 2 in the middle, and then there are 2 at the bottom, as you can see over there. So when you undo those 6, the PCB you see in my hand right now just flips out like this. So if you stand the chassis up, it will drop down. But, well, of course you shouldn't let it drop of its own accord. You have to sort of help it down, so not to damage it. Anyway, now that I have this PCB out of the chassis, I can say 2 things. One, working on this PCB will be a lot easier now that it's out of the chassis. So that's a good thing. I will be able to reach these capacitors you see here, and which in my opinion I would do good to change or to replace. Then there is the big fat electrolytic you see here, which in my opinion definitely needs replacing. The inside is rather dirty, but that was to be expected, of course, so I don't think that will cause too much problems. Also, what I notice is that the stand, which normally holds the picture tube, is bent. As you can see, somebody in the past must have put that much pressure on it that it's bent completely backwards. So instead of standing like this, it's bent like this. So sooner or later I will have to disconnect this or unmount this and bend it back to its right angle, which might be a tricky job because I have to align it precisely with the opening, the opening in the head, the projector head. So that will ask quite a bit of doing. Anyway, so the next thing to do for me is to identify all the capacitors that need to be changed, make a short list of them, and then an inventory of the parts that I own, and see which ones I can readily replace. If I don't have all of them, well, then I'll be forced to order them. By the way, I don't know if you can see this, but I'll point to them. You see two old type of diodes. You see here, you see this one, and then you see that one over there. So these are the, let's say, vintage equivalent of what we nowadays would call a 1N4007 diode. I think, although I'm not sure, these are germanium diodes and not silicium diodes. Actually, these two are used as a rectifier for the power which comes from this small power transformer down there. I seem to remember that there is also a fuse, and if I remember correctly, watching one of Bob's of the B. Anderson TV channel videos, the fuse is inside this tube. I don't know if it's good, but let's go ahead and measure it out. Why not? Okay, I need 2 crocodile clamps. So let me take 2. So, okay, so put one here. Then I put the other one there, like this. And then I put the crocodile clamps on the test leads of my multimeter. Let's watch what the meter says. It's okay, I think you can see it now, and there we go. Yep. Okay, so the fuse measures good. So that's good news. Temporarily, therefore, I won't need to change or to replace the fuse, which is perfect. That saves me a little bit of work. And anyway, if I can, I will try to keep the parts which are in here more or less authentic, which of course implicitly forces me to sort of salvage these tubes, the tubes which are around the paper caps, and mount new caps inside. Oh dear, oh joy. But well, okay, I suppose a Philco Safari is rare enough to at least try and make an effort of changing, of keeping it as authentic as possible. Also, what will definitely need to be repaired is the battery connector. As you can see, one of the wires of the connector just let go. So I'll need to repair myself these deep freeze zipper bags. They really don't cost a lot, and they are damn useful if you want to keep together all sorts of parts from the chassis or whatever. You can write on it with an alcohol pen, and you can wipe what you wrote on it later with an alcohol swat if you want to reuse it. Also, it's big enough. These are 1 liter 1 liter bags, so they are big enough to contain quite a few parts. As you can see, there are just a few screws in it right now. So believe me, these zipper bags are well worth the money. They don't cost that much. I think a box of 25 cost me €2, which is, I would say, $2.50. So it's well worth the investment. Okay, the structure on the inside of the Philco is constructed as you see here on this exploded view of the internals of the chassis. So the left board, you'll remember, which I unmounted, this one, is actually this one, and according to the schematic, it's a video, sound and sync PCB. The central part, which also consists of the power supply, the yoke, the speaker, and at the back the tuner, is this board. They call that simply the chassis and vertical output PCB. So the vertical output, you'll remember, is this little board up here. Yeah, so that board is the vertical output board, or the vertical deflection board if you prefer. And then there is the channel selector, and the channel selector is that little box down in the upper right corner, which is connected by the channel knob on the outside to the other PCB at the back. You can only see part of it, but it's called the sweep printed board. That's a bit a peculiar kind of denomination, but I would say this is the horizontal sweep PCB with, you can see here, the high voltage part. Yeah, so which is for the moment a bit out of view. It's actually constructed inside the little metal box, which you see down in the corner there. Now that will take a bit of doing to unmount that, and actually I'm not too fond of the idea of disassembling the high voltage gauge, because that's what it is, but in miniature. I'm really not very enthusiastic about disassembling it, but I guess if I'm going to take the effort to change all the capacitors, well, I might just do it anyway. I decided that I wouldn't make a inventory of all the capacitors in the Philco Safari at once. The TV, as it is built, is just a little bit too complicated to be completely disassembling it just to get to all the capacitors at once. You might say I decided against tackling complexity. So rather than effectively disassembling it completely, I will disassemble it PCB by PCB. So now I'm tackling the, you could say, the tuner board, or the tuner part of the Philco Safari. And as you can see, there are a few paper caps on it, which need, in my opinion, a replacement. I counted them, there are 7. I made a short list of them, as you can see here. So there are no special values, and as a matter of fact, Philco uses a special kind of code to code each type of capacitor. In effect, these long numbers are not exactly part numbers, but rather type numbers, and you should take care when reading those part numbers. Because, for example, on the PCB there are two 0.33 microfarad capacitors, 100 volts, yet they have different part numbers. You see, this one here has a part number ending on 33, while the exact same value has a part number ending on 3, not 33. But at closer inspection, it seems that this type, with type number 3 ending on 3, has a 10% tolerance, whereas this one, with type number 33 at the end, has a tolerance of 20%. So it does matter what type number the parts have. But aside from that, they all have more or less the same size, or I should say they all have the same size, and they are quite easy to get at. So unmounting them shouldn't pose too much of a problem. And in fact, if you take a close look at the PCB, you see that each part has a code. You know, C19, like capacitor 19, C17, capacitor 17, etc. You know, TR8, transistor 8. So every part has its code. If I take enough pictures of the PCB before unmounting the parts and eventually writing down their code numbers too, I mean these codes which are marked on a PCB, it shouldn't really pose that much of a problem to unsolder them and replace them with new value capacitors. Now, as you can see, I also unmounted the capacitor which was attached to the pins, the output, you could say, of the power supply, and it was encased in this wax coated cardboard cover. It only says that it's 2000 microfarads, 10 volts, and the part number. But aside from that, it doesn't say a lot, except that it's 65 degrees Celsius tolerance, temperature tolerance. In any case, I'll have to find an equivalent 2000 microfarad capacitor to replace this one. And if you notice, on the positive end of the electrolytic, you see a bulge here in the polymer coating surrounding the anode of the capacitor. And in my opinion, that might mean the capacitor is damaged inside. Perhaps not, but well, it's not a good sign that there is a bulge. Okay, so this is the first one I unmounted. I will be unmounting all the other capacitors, and I'll make a small inventory of what I have. I mean, the capacitors I already have, and if I have sufficient numbers of them and the right type, then I'll be changing all these paper caps you see here. This one, that one, those two, the one at the back, then this one, and this one. So that will be my job for the next few hours. When this is done, I'll remount the power supply filter capacitor, and I'll remount this PCB onto the chassis. Then I will unmount the right side PCB, this one, which is the high voltage PCB. And I'll do exactly the same thing with this one. So I'll make a short inventory of all the paper caps and perhaps other defectuous parts, then see if I have them, if not order them, and then replace them. And then I will end with this top PCB here, which is the vertical deflection PCB. And once that one is done, then I think I might have enough courage to open up the high voltage cage which you see here, inside which, according to the schematic, there must be two tiny high voltage vacuum tubes, and more specifically a kind of diode vacuum tube. Don't know yet if I'll do it, but curiosity is a powerful motivator for me. So probably yes, in the end I will end up opening this high voltage cage too. So have a little patience, bear with me, and stay tuned. Another update will follow soon. Thanks a lot, guys. Bye.